All right, so to start with, inverse functions must be first one-to-one functions. So if you remember what a one-to-one function is that for every x there is exactly one y. What that means is that for every input there is exactly one output. So for a function to have an inverse, the most important thing to remember about it is that the x and the y switch places. So a one-to-one function, if I started off with a table of points for x and y, if this was 2, 0, 4, 3, 5, 9, then the inverse function, the x and the y switch. This is why a function must have a one-to-one relationship between the x and the y, because then the inverse function would be 0, 2, 3, 4, and 9, 5. What happens is along this line, and this is my line y is equal to x, the function will rotate. So if I go ahead and first graph f of x, which was 2, 0, 4, 3, where the function looks something like this. Then the opposite function, my inverse function, is going to be 0, 2, then 3, 4, and then 9, 5. And if you could imagine folding this graph along the line y is equal to x that I drew here, those two functions would map on top of each other. So inverse functions, the x and the y switch. Just important to remember that in order for a function to have an inverse, it must initially be one-to-one. Now, I just talked about finding the function and the x and the y value switch. Well, before I do that, I need to know what the domain of this function is and the range. Because when I go through and find the inverse function, the domain will become the range, and the range will become the domain. They do switch. All right, so this is a square root function. I see here that I know that x minus 1 must be greater than 0. And again, I know that because I just set the argument of whatever is underneath the radical greater than or equal to 0. So my domain here is x must be greater than 1, which I then going to go ahead and follow that along. And I know that the new function, my inverse function, is now going to have a range, and that range switches. So now that means my range is going to be y is greater than or equal to 1. Now, for the range of this square root function, I know that the output, meaning what can come out of a square root, well, has to be greater than or equal to 0. So that means my domain for the new function is going to be that x has to be greater than or equal to 0. Now, what are the steps for finding the inverse function? Well, we start with our original function, which is f of x is equal to the square root of x minus 1. Then my first step is to take f of x and replace it with y. And that would be the square root of x minus 1. And now I want to go ahead and swap x and y. Wherever I have x, I replace it with y. So when I swap them around, what that means is y becomes x and x becomes y. So x is equal to the square root of y minus 1. Now I need to solve this. The way I solve and get y by itself is I square both sides. And now I'm left with x squared is equal to the square root of anything squared is equal to whatever is underneath the argument. So this is equal to y minus 1. I solve this for y. And I'm left with x squared plus 1 is equal to y. And then lastly, I replace that with my inverse function. Just remember to make sure that you always list your domain and range as we had above here in the beginning. The domain for this, x must be greater than or equal to 0, and y must be greater than or equal to 1. All right, let's go ahead and do one more. This time we'll go ahead and let h of x equal 5 over x plus 4. The domain here is that x cannot equal 0. Now, the range is kind of tricky to see, but think about this. If I could make all of 5 over x go away and make that equal to 0, which I can't, right? So that means I would have to add 4 to that. So since this first piece inside here can never equal 0, that means my range, my y, can never equal 4. Because the only way it could equal 4 is if my first fraction was 0, which is not possible. So therefore my range cannot ever equal 4. Now we're going to go through and find the inverse function. So my inverse function, my first step is to replace the function notation with the value y. So I have 5 over x plus 4. My second step is to switch the x and the y. So I rewrite that as x is equal to 5 over y plus 4. And now we have to solve for y. I do that by subtracting 4 from both sides. And when I subtract 4 from both sides, I get x minus 4 is equal to 5 over y. Now I need to solve for y. The way I'm going to do that is I'm going to multiply both sides by y. And I'm just going to leave this way for a second because I'm going to use the same technique. And now I'm going to divide both sides by x minus 4. Of course, you can do this in one step if you want. And I'm left with y is equal to 5 over x minus 4. And the last step is to replace that with my interval with my inverse function notation. So the inverse is equal to 5 over, and remember the domain and the range switch. So while it started up here, my domain was x cannot equal 0. That means that changes it to that my range y cannot equal 0. And coming back over, if my range started off was y could not equal 4, that means over here my domain x cannot equal 4, which absolutely matches with what I have right here for my inverse function.